A hot dog manufacturer claims that its hot dogs have an average fat content of mu equal to 18 with a standard deviation sigma equal to 1 gram. 18, this should be 18 grams, so I'll write G. Okay, G is short of grams. Okay. A consumer organization selects a simple random sample of n equal to 36 hot dogs from this manufacturer. Suppose that the sample mean x bar of this sample is x bar equal to 18.4. Does this mean that the manufacturer's claim is incorrect? So we are going to deal with sampling distribution. Or probability distribution of x bar. Remember, x bar is the sample mean. So how does it look like? Well, from central limit theorem, since n is equal to 36, which is n is greater than, so let me correct that, n is 36. Okay. Okay. From central limit theorem, the sampling distribution is bell-shaped. That means normal. With mu x bar, which is the mean of sampling distribution. Mu x bar is equal to the mean of the population. Okay, population. I will complete it here. Okay. Further, we also know from central limit theorem, when n is greater than 30, sigma x bar, which is the standard deviation of the sampling distribution. Deviation of the sampling distribution is equal to sigma divided by square root of n. So, therefore, mu x bar is equal to 18 gram. That is claimed by the manufacturer, mu x bar. And sigma x bar, which is the standard deviation of the sampling distribution or probability distribution of x bar, is sigma divided by square root of n. So how to do that in the calculator? The manufacturer said that the population standard deviation is 1, that is divided by square root of 36 sample size. So in TI-84, you can first do 1, then divided by second button and x square button. That will give us the square root, inside the square root 36, and enter. So sigma x bar is equal to then 1 divided by second x square root of 36, and that is equal to 0.1667. Okay, so let's draw the sampling distribution. We know the sampling distribution is bell-shaped. So this is the sampling distribution of X bar. That means we have X bar values on the horizontal axis and probability on the vertical axis. Now the center, where the peak is the highest, this is mu X bar. So as we just discussed, mu X bar is equal to mu equal to 18 and sigma X bar equal to, we calculated it out, is 0.1667. This is sometimes called the standard error. Actually, it is the standard deviation of the sampling distribution of X bar. Now, if we read the problem, the consumer organization got a sample mean of 18.4. So they got a sample mean of 18.4. Let me change the color of my okay. So the center is 18. That is the mean, and we got a sample mean, or the consumer organization got a sample mean of 18.4, which is slightly greater than 18.4. So to answer the question, whether the manufacturers claim is correct, let's calculate probability of X bar greater than 18.4. That is, find the area under the sampling curve sampling distribution to the right of X bar equal to 18.4. So basically, again, if I change the color of the ink to red, this is the area I want to find out. What is the area to the right of 18.4 under the sampling distribution curve? So this can be easily done with our calculator. So we are going to use, let me change the ink back to blue. Okay, so remember this is 18.4. Okay, so in our calculator use TI-84. So in TI-84 we are going to press the second key, which is in the top left, and then the worst key, which is in the third row of keys from the top, and then select number 2. Okay, this is normal CDF. Okay, so normal CDF we have selected. Second button, and then worst button, and then number 2 is the normal CDF. Now we are going to start our calculation from 18.4. No, we are going to change it to red. So, and we go all the way to the infinity. Remember, this curve stretches to infinity, or a very large number on the right. This is important. So the lower boundary, lower, will be where we are starting our calculation from, 18.4. And the upper has to be a very large number on the right, which we indicate by 1 exponent 99. E stands for exponent. That is how many zeros are after 1. We are going to put 99 zeros. We cannot type it in the calculator. So instead, we will first type 1. Then we will press the second button. And then the comma button. Where is the comma button? On top of the 7 button. This will give you the capital E 99. 1 followed by 99 zeros. Okay. And then we are going to type our mean, which is 18. And the sigma. We have to be careful. Here is the sigma x bar, or the standard deviation of the sampling distribution that we type in. Okay. And then we go down to paste. Bring the cursor on paste. Whenever we are on paste, hit enter twice. Okay. So we are starting our calculation from 18.4. Our upper is a very large number on the right, which is 1. Then second button and comma button on top of the 7 button gives me the small cap E, which stands for exponent. This is 1 followed by 99 zeros. Very large number. Very large number. Okay. 1E99. Mu is the mean of the sampling distribution, which is same as mean of the population. The sigma, we have to be careful, is not the sigma of the population, it's the sigma of the sampling distribution, which we have already calculated as 0.1667. Okay. So now we go down to paste, enter twice. And we find that let me change the color back to blue. That probability of x bar greater than 18.4 is only 0.008. What does it mean? There is a 8 chance of the sample mean to be greater than, or at the same time greater than or equal to 18.4. Okay, there is a chance of the sample mean to be greater than or equal to 84 of 8 in 1000. Okay, why 1000? Because we have 3 places of decimal. After the decimal point, we have 2 zeros and 8. That means it's 8 in 1000. This is a very low chance. So there is something wrong, because the sample mean is the sample is coming from the population, and the sample is coming from the population whose mean the manufacturer claims is 18. Okay, whereas the sample mean came out as 18.4, which is very unlikely to happen, or sample mean of at least 18.4 is very unlikely to happen if the population mean is 18. Population mean as claimed by the manufacturer. Population, there is a sample mean of at least 18.4 is very unlikely to happen if the population mean as claimed by the manufacturer is 18. In other words, the manufacturer's claim of, or in other words, the manufacturer's claim of population mean equal to 18 is very unlikely to happen. Very unlikely. That is most probably the population mean is greater than 18. You can understand the situation. You get a sample mean of 18.4, whereas the manufacturers claim the population mean is 18. So how can a sample mean be so high, 18.4, so far away from the population mean? The population mean most probably is greater than 80. That means the manufacturers claim the manufacturer's claim is incorrect. Okay, so I stop here today. So manufacturer is making a false claim because the probability of a sample mean of 18.4 is very low. That means it cannot happen, the event X bar greater than 18.4 or equal to 18.4 when the population mean as claimed by the manufacturer is 18. It has to be higher than 18. Okay, so the manufacturer's claim is incorrect. I stop here today. If you have any question, comment, write me a note. I will get back to you as soon as possible. If you like this video, please give me a thumbs up. I appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. Also, please do not forget to click on the bell button because that will notify you every time I upload a new video. Please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day.